In this video, I'll show you a super fast way to create timber truss roofs that I've been refining over time. You basically pick the truss you need and drop it exactly where it belongs. What makes this really powerful is that all the timber connections already come with the correct cuts built in, so everything lines up perfectly without extra work. Stick around, because I'll show you how these families work and how you can get them to speed up your own projects. I'll see you in the next. Before we get started, you should know this is not the usual way to model timber trusses. If you want to learn the standard workflow, I recommend checking out these other videos from these guys. They're so great, and they'll show you the traditional approach step by step. But if you want to see how I model my trusses way faster than the traditional method, I'll walk you through it in this video. First, I'll show you what you can achieve with this method. And if you find it useful, you can keep watching the rest of the tutorial for free, where I break everything down step by step. For this quick example, I'm going to use a gabled roof, very similar to a typical residential project. At the same time, I'll be showing both the 3D view and a section cut. Alright, the first truss I'm going to place is the standard truss, also known as the S type, which you can find here in the project browser. Just a heads up here, don't look for these families under the truss category, since these families are actually built as structural framing, not trusses. Select the standard truss. You can download this one as a sample from the link in the description or the pinned comment. Once you've got it, just drop it into the plan view. Press the space bar to flip its orientation until it lines up the way you need. Once it's pointing in the right direction, place it anywhere along the ridgeline. As you can see, just by placing the truss without touching any parameters, all the connection cuts in the timber members are already there. This is very different from the traditional process, where after creating the truss, you still need to manually adjust all those cuts. From here on, all we need to do is tweak a few parameters so the truss fits the roof layout. To do that, I'll just shift the section cut closer to the truss so we can see it clearly in elevation. To adjust the truss properly, we need three main values: the distance from the outside face of the walls, which defines the truss span or truss length, the eaves overhang, and the roof slope or pitch. In this case, the truss length is 7,500 millimeters, the eaves length is 600 millimeters, and the roof pitch is 20 degrees. To change these values, select the truss and click Edit Type. Now enter 7,500 for the truss length and 20 degrees for the roof pitch parameter. To adjust the eaves length, we first need to close this window by clicking Accept, so the changes are saved. With the truss still selected, look at the Properties palette. Under the Construction section, you'll find several parameters that we can tweak independently for each individual truss. I cover all these features in more detail in the next videos, but for now, we're just going to quickly check that both the left and right eaves are sitting at 600 millimeters. If not, just tweak them a bit. Easy. Okay, first truss is in. Later, we'll just copy it along the roof once we know exactly where each one should go. Next up is the girder truss. This one usually sits 2 or 3 times the normal truss, spacing from the wall edge. Let's say, for example, our spacing here is 900 mils. 3 times that is 2,700. It means that would be somewhere around here. I'll pop a reference plane right here at 2.7 meters from the edge of the wall. Now, jump over to the project browser, find the girder truss, or GT type, and drag it into the plan view. Hit the space bar to flip it the right way, and once it's lined up, click once to drop it at the top of the ridge. Then grab the Align tool and snap it to the reference plane. Click Edit Type and set the length and roof pitch, just like we did with the first truss. Jump into 3D view for a sec. You'll see the truncated truss has its 45-degree cut on the opposite side, as the hip trusses should come in this direction and not in the other way. To fix it, pop back to plan view, select the truss, and nudge it with these little control arrows. To get a better look, I'll move the section view close to the girder truss so we can see it in elevation. Here, you can adjust the support height of the truncated girder truss using this blue arrow. Just drag it up or down to whatever height you need. Yep, just like this, and the truss adjusts itself automatically. We'll lock in the final support height later when the hip trusses are in their final spots. Alright, now let's space out our standard trusses from the girder truss. I'll speed through this part. Quick note, I'm only adding standard trusses halfway across the roof. The other side will just mirror later. Once we have the standard trusses in place, we can already see that the truss right after the main one is sticking up above the ridge. And yeah, that's not what we want. So because of that, we need to swap this one for a different truss type. I select it, then in the Properties panel, I open up the type list and change it to the truncated standard truss. Now, let me jump into the 3D view and isolate the family real quick, just so we can clearly see what's going on here. As you can see, just like with the main truss, we still need to use the control arrow to mirror the cut on the corners of the truncated cord. We'll deal with the support height later. For now, I'm just editing the truss to give it a length of 7,500 millimeters, and I'll double check that the pitch is set to 20 degrees. Alright, next up we have the hip truss, which is the one that sits right at these corners. To place it, I go to the project browser, look for the family called hip truss, and I just drop it into the structural plan. Before placing it though, I can hit the spacebar to rotate it and line it up with the corner where it needs to go. If I'm working on this bottom corner, a single tap on the spacebar usually gets it aligned correctly. Then I just click on the corner of the load-bearing walls to finish placing it. To place the one on the opposite side, I press the spacebar again once. Well, no, maybe twice, until I get the exact orientation I need, and then click to place it. Now let's quickly check the 3D view to make sure the trusses are facing the right direction and nothing is flipped the wrong way. At this stage, they're still not dimensionally perfect, and that's fine. Right now, I'm only checking two things: that the slope is 20 degrees and that the eave length is 600 millimeters. To fine-tune the dimensions, I go back to the plan view and select one of the trusses. Notice how, as soon as I select it, 3 blue arrows pop up. The first one controls the starting point, the second one is the distance to the main truss, and the third one controls the distance to the ridge. I just shift these arrows manually. I start with the first one, roughly eyeballing it, since we don't really have a clean reference yet. Then I move the second arrow straight to the main truss. If we jump back into the 3D view and zoom in where the trusses connect, we can see that the joint has been generated correctly. From here, we can either repeat the same steps for the other hip truss, or honestly, it's faster to just delete it and mirror this one, using the ridge as the reference. Now let's move on to the creeper truss. You'll notice there are two types available, a standard one and another one called corner array. I'm going to use first the corner array family, as I want to place all of them here in this corner. I'll drop it into the floor plan, and just like before, I'm just going to place it directly on the corner of the load-bearing walls. In the 3D view, I double check that it's sitting correctly, and then I adjust its parameters, mainly the slope and the spacing between trusses. Once that's done, I mirror it to place the same truss array on the opposite side. To wrap up this section, I grab the family called Jack Truss and drop it into the floor plan. I place the first one right at the center of the roof, aligned with the ridge. If you don't have a perfect snap point, no worries. Just place it slightly off and then align it using the ridge as a reference. I select the truss and Like with all the previous ones, I check its dimensions and the slope angle. Then I go back to the structural plan to adjust its deflections, the same way we did with the hip trusses. I extend the first deflection to the ridge and the second one to the main truss. Finally, I copy the required number of trusses to fill in the remaining space, making sure the spacing stays consistent and making small adjustments as we move toward the center of the roof, where the loads are higher. I copy the first truss and place it 900 millimeters away from the last creeper truss. Once it's in place, I select it and modify only the top line, since the distance to the main truss stays exactly the same. Next, I align the second truss relative to the hip truss. If we want to be a bit more precise here, we can actually measure the exact distance from the outside face of the wall to the hip truss, and then just type that value directly into the length parameter of the element. In this case, the 45-degree miter cut direction is already correct. But if it was flipped the wrong way, no problem. We can go back to the plan view and use the flip controls to fix it. Now, I'm going to mirror this truss to place its equivalent on the opposite side. After that, I need to tell the central truss that it shouldn't have a 45-degree miter cut. And on top of that, it needs to extend far enough to connect with the hip trusses. I do the first part by using the top chord miter parameter and setting it back to 0 degrees. For the second part, I simply go back to the structural plan and start extending the truss, while at the same time checking the 3D view, just to make sure the length is actually enough. Not too short, not too long, just right. Before copying all the trusses to the opposite side of the roof, I'm going to add another cross section right here in the middle so we can adjust the support heights of the truncated trusses. As you can see, this truss is supposed to be supporting these others. So I select the truncated truss and use this blue arrow to roughly shift it up to the required height. I do the same thing for both of them, making sure they're sitting directly under the timber beam. Then I jump back into the 3D view to confirm the changes. Alright, now all the cross sections line up correctly. To finish things off, I select all the trusses and mirror them. Just keep in mind that these families are not structural trusses. They're actually structural framing elements. So when you're selecting by filter, be careful not to accidentally grab other elements, like concrete beams for example. In this case, I'm going to manually deselect these concrete beams, which by the way, are also one of my dynamic families. They already include 2D reinforcing steel, so you don't need to model it manually, and they automatically quantify both the concrete volume and the reinforcing steel weight. If that sounds interesting, I've added a card right here so you can check them out. Once I'm sure that only the trusses are selected, I apply the mirror tool, using half of the roof as the reference. And with that, we've wrapped up a basic roof model. Now, of course, in real life, it's never this clean or this simple. That's exactly why I've also created other truss types to handle most of the real-world scenarios you'll run into on actual projects. In the next videos, I'll walk you step by step through how to build a more complex roof, using additional truss types like valley trusses, mono-truncated trusses, roof rafters, hip rafters, and even this really cool gable end truss. With this one, you don't just get the truss itself, you also get all the outriggers built into the same family, so you don't have to worry about modeling every single outrigger one by one. If you want to download the families and follow along with the tutorial, you can download them from the link in the description. Or if you're still not totally sure, no worries. Please feel free to download the sample standard truss for free in the same link. And continue watching the second part of this tutorial by clicking on this link. Alright, thanks for watching and I'll see you in the next one.